Okay. All right. We will be starting here in about 2 minutes. All right. Just waiting for 11 o'clock. Happy Thursday, everybody. Let me just make sure that we are live on LinkedIn. Hello, LinkedIn. Good morning, good afternoon. All right. And yes, we are live. Awesome. Okay, we're going to go ahead and get started. We're a little bit early, but that's okay because we have 2 speakers today. So we want to make sure we have plenty of time. So good morning or good afternoon, depending on where you are in the world. My name is Lauren Martin Clemens, and I am the head of marketing at Pipestream. It is the 3rd Thursday of the month, which means it's time for another Pipe Up webinar where we deep dive into the expert minds behind Pipestream. Today's webinar is called Speak Fluent AI, choosing the right NLU tool for smarter conversations. And our speakers today are Winslow Marks and Sofia Vizitiu. Winslow is, and wave for me, Winslow, thank you. Winslow is a non-binary linguist who has been working in machine learning models for just shy of a decade. They started their career working on Amazon Alexa, identifying issues with the speech recognition and natural language understanding models and recommending resolutions. After that, they had a brief stint working as a copywriting prompt engineer before becoming a solution designer at Pipestream, where they get to combine their experience working with AI with a variety of other technologies. Sophia, wave for me, Sophia, is a solution design lead at Pipestream, where she leverages AI, automation, and conversational design principles to create custom solutions that solve enterprise problems. Prior to her time at Pipestream, she was a consultant at IBM, specializing in Watson AI implementations. She holds a degree in cognitive and brain science with a linguistics concentration from Tufts University. All right, please take it away, gang.
All right, thank you for the intro, Lauren. Let me share. Are y'all seeing my screen?
We can indeed.
Amazing. Okay, thank you. Hello, everyone. Thanks for joining. As Lauren said, we're going to be discussing NLU tools and which is the right one to pick for your use case. We've already had a few webinars in the past covering NLU in general, generative AI in general. So this is an opportunity to get a bit more tactical around the actual approaches and tools available and which are most appropriate for your use case. So I'm going to go through a few pieces of content. I'm going to pass it off to Winslow. They're going to discuss a few things as well, and we'll sort of just cover all these topics in tandem. All right, so the goal of this, forgot I had animation set up here. The goals of this are really just to give an overview of the approaches available, comparing their strengths and weaknesses across different use cases. So we'll do a bit of review on what NLU even is. Some of this might be familiar if you've joined some of our NLU-focused webinars in the past, but it's good to just level set and sort of remind the audience of kind of the key topics and I guess themes involved here, why NLU is recommended and nice for conversational automation, some of the tools and approaches that are available, specifically intent recognition, entity recognition, and then generative AI, and then just a comparison around all 3 of those. So quick overview of NLU. NLU refers to machine comprehension of spoken or written natural human language, and it falls kind of within the overall umbrella or area of NLP, which falls within AI in turn. So on the right here, we have this sort of orb representing NLP, natural language processing. So NLU focuses specifically on the understanding part of the processing. NLG, natural language generation, which is where generative AI falls, that is also within that umbrella, but it kind of focuses more on the generation or the creation of language, which overlaps with understanding, as you might imagine. There are a few kind of core components or themes within NLU that come from the domain of linguistics. So there's syntax, so the actual grammatical structure of sentences, breaking that down and understanding the different components of a sentence. Semantics, so once we have that broken down, what do the actual different chunks mean? What is the meaning that is being conveyed? NLU also needs to understand pragmatics or context clues. So, a given syntactical structure might sort of mean a different thing in one context as opposed to another. So NLU should take into account all these sort of different levels at which language operates, and kind of have an understanding of each to arrive at a naturalistic comprehension of what a human might be trying to convey. Common applications in which you have likely encountered NLU algorithms in your life are virtual assistants, obviously, Pipestream's bread and butter, text classification, so sort of automated approaches that attempt to bucket text in one category or another. Your email inbox likely does this, as far as tossing different emails into different sort of folders depending on the content. Sentiment analysis, so sort of understanding, hey, here's a tweet. Is this person angry? Is this person happy? This might be really relevant for brands, understanding how the perception of their products is on social media. And then smart search, so if you're Googling something, you get sort of smart suggestions or the sort of like options that populate as you type in your sentence completion, that type of thing. Why would we want to leverage NLU? So the benefits are, there are benefits for both customers and businesses, both sides of the sort of interaction here. So in a kind of business or conversational use case, customers can benefit from NLU in that it makes communication much more natural and much more human. So rather than users having to sort of communicate with a virtual assistant in a very sort of inhuman way where they're kind of like clicking and trying to understand where things live, they can express their desire or their question in exactly the same way they would to another human being. And NLU can sort of pick up on their goals and take them to the right place. So in that way, we can meet the user where they are rather than them having to learn how to interact with a novel tool. It also makes navigation much easier. Users can just come right in and say what they want immediately rather than having to navigate through like 3 different layers of options in a menu or a nav bar to find what's available and hopefully what they're looking for within what's available. And then once we bring in tools like voice, it can be very convenient and accessible. It can be sort of a hands-free way of interacting with a tool or an interface. And then for businesses, obviously all of the things I just listed will increase customer satisfaction through the additional flexibility and convenience that users are getting. NLU can also be sort of a really great way to understand what your users are asking about, their questions, the things they would like to see, their challenges. That's where some of that sentiment analysis and some of that analytics can come in to see, like, where are the gaps in terms of what we're offering and what users are actually asking about that they're expressing via their utterances. And the sort of leveraging NLU can also make some of these business processes a lot more efficient. And that can sort of help to just move users through the pipe a lot more quickly and get them what they need. So now that we've sort of reviewed what NLU even is, we're going to get a bit more specific in terms of some of the approaches that are available that we like to use a lot here at Pipestream. So first we have intent recognition. This refers to an AI system's ability to sort of understand the intent behind what a user is saying, to understand the main topic or the main goal that they're expressing, and to categorize that into one of a number of buckets that have been defined in advance. At a very high level, not getting too into the weeds technically, the way this works kind of under the hood is it's a machine learning approach, and it leverages supervised training. So supervised training means there's like a human being who is training the model. It's not just sort of learning on its own as it goes. The models are trained on what we call labeled examples, which is sort of a given sentence that the model might expect at runtime, and then the correct intent, the correct bucket for that sentence. And you really want like a pretty large number of these. So once you've trained the model up on that training data, and it has sort of a general understanding of the different intents it's supposed to care about and what a sentence might look like within that intent, at runtime, incoming text comes in, it's parsed, the model analyzes it, and the model buckets it into what it believes to be the most relevant intent based on its training. And usually a confidence score also gets returned, so we can understand, okay, the model is 100% confident, there's no doubt in its mind that this sentence belongs to the I want to place an order intent. Or, you might get lower confidence where it's like, I'm pretty sure it belongs to this intent, but not positive. This is sort of a new type of sentence I've never seen before. This is my best guess, but there's a bit of doubt. So that confidence score can be useful in terms of sort of your downstream logic of disambiguating with the user, confirming with them, hey, is this what you're asking about? Versus, a really, really confident classification, you might just go right into the content that is relevant to that classification without sort of double checking with the user. In terms of what it looks like, so I have a few screenshots here of what it might look like on what I'm calling the back end, but this is really more just sort of the view that you would get as somebody who's actually training these models versus the view in the front end that you might get as somebody who's interacting with these models. So here I have a screenshot of an intent here that I'm calling missing items. And this is for sort of a food ordering use case. Like if you get your food delivery and your fries are missing, you might come into an interface and sort of complain about it. So we have missing items, and then we have some sort of representative utterances or sentences that would correspond to this intent. So, I didn't get part of my order. You guys forgot my fries. Some of the things in my order are missing. So the main idea here is to just capture sort of a bit of variability in terms of the way users might express this intent, so that we can prepare the model with the whole, as to the extent possible, to expect sort of the wide array of human creativity and expressing frustration about items being missing. And then once this is deployed in the front end, the user comes in, they express a sentence that isn't exactly the same as any of the sentences this intent was trained on, but is close enough that the model can accurately capture it, bucket it into the intent, and then we can sort of double check with the user that that's what they're asking and just send them into the right place. So we're confirming with the user, sounds like there's items missing, and if they say yes, we'll take them to the predefined content or flow that is appropriate for missing items. So in this way, rather than force the user to sort of navigate through a series of layered menus, they can just give us their issue right at the beginning, and we can take them to the right place. As far as the setup and training, just some high-level best practices. You should have a good idea of what you expect users to ask about, either based on like analytics from past user requests, something like that. And that should be translated into your list of intents. So you have like pretty good coverage of matching what you're expecting and what users are actually going to come in and ask about. Intents, we want to train with, at a bare minimum, 10, but hopefully more utterances that capture the variability that we're expecting and how users might ask about those intents. Real world, when I say real world, it's good to have data that is things users have actually said. So, if there's like an existing contact center, or if you're tracking what users are coming in and talking about, then that's a really rich source of data, because it reflects, whatever sort of jargon or usage your actual real world customers use, rather than sort of our best guess as to what they might use, which may or may not be, fully informed or accurate. In a perfect world, we always have real world data, but in the real world, we often don't for various reasons. So if that is the case and there just isn't that much or is no real world training data at all, you might just use synthetic data to build sort of your first model and then rapidly augment it and improve it over time with real world data once it's live, and like you're having that analytics trickling in of how users are actually engaging with your model. Generally, we want each intent to be equally trained in terms of number of utterances, unless there's a really use case specific reason that you would want to weight some intents more heavily than others, meaning you would want to sort of predispose the model to classify one intent over the other by just overtraining it comparing to the others. The confidence threshold I mentioned, you might want to tweak it depending on your desired user experience. You might want to require a higher confidence threshold if you really want your model to always get things right and always sort of check with the user double check the classification if you're not sure, or you might want to make it lower if you want to prioritize direct matches and just getting the user somewhere in the flow without double checking with them. And overall, with this type of model, it's important to have kind of analytics in place and keep track of your performance after launching, because your V1 model that you go live with is not going to be perfect. There's likely going to be a lot of gaps, which is expected because you don't know what you don't know until you know it. So users are going to come in and interact with your model in surprising ways, and that will drive sort of iterative improvement over time, whether that's retraining existing intents, adding new intents that you didn't anticipate users would ask about, removing intents that just turned out not to be relevant, or what have you. Okay, so that's intent recognition. Moving into entity recognition, this is also sort of a subtask that exists within the world of NLP. This is one in which named entities are extracted from unstructured text and classified into predefined categories. So a named entity is really any type of keyword that you might care about. It might be like a country, a date, a phone number, maybe like a paint color, like anything like that, where there's specific words or pieces of information that you want to extract and say, okay, this is the user's name, this is the location they asked about, this is the date they supplied, anything like that is going to be an entity recognition task. So in terms of how it works in the back end, it leverages similar sort of machine learning approaches that are used by intent recognition. So supervised training, again, these are statistical models that are trained on data sets of labeled examples. So the labeled examples in this case would look like a given sentence. I want to place an order for this type of sandwich and remove the mayo. That sentence is going to have annotations that reflect the entities we care about and the categories to which they belong. So in that sentence, sandwich might be an entity we care about, and that might go into like an entity type that you're calling main item or something like that. And then mayo is also likely going to be an entity you care about, and that might be categorized into an entity type called topping or condiment. So your data is going to have all those different annotations reflecting the different entities that are in the sentence. And then at runtime, your model is going to be able to take in a sentence and extract the entities you care about, where they occur in the sentence, and the types to which they belong. Usually entity recognition platforms will also have synonym dictionaries that you can upload. So for, going back to our example of condiments, you might also be able to say, here's a list of every, mayo, ketchup, mustard, relish, like everything a user might ask about. So you don't necessarily need to have a real world example with each of those. Like you can just sort of upload a dictionary to just cover your bases and have the fullest of words that you expect might come in under a particular entity type. We also usually get confidence scores similar to intents, so we can see how confident the model is in a particular classification of an entity that it encountered. So what it looks like. So similar sort of layout here. These screenshots are from sort of a travel or flight booking use case. So on the left, we have sort of screenshots of what it looks like to set this up. So this one on the left here, we have some training phrases, and you can see those annotations I was discussing. So in this case, this entity that we care about is locations or cities. So I want to know about Lahore to Bahrain. So we have Lahore highlighted, that's a city. We have Bahrain highlighted, that's a country. Pakistan is a country. And then we have some other entity types down here. So 8 April, that's a date. CCJ, that's an airport code. So we're highlighting all of these things. We're labeling them as the entity type to which they belong. So the model can learn not only here are the words that might occur at this entity type, but also how do these entity types behave in a sentence? Like what's the sort of sentence structure or syntax in which we might expect some of these entity types? So for cities or airport codes or countries, we get a lot of the structure of like from X to Y. So once the model sees that sentence structure tied in with those entity types over a large number of training utterances, it will learn to identify, even if it gets a brand new city that is not in the training data, a city that we didn't expect anyone to ask about. The goal is that the model will be able to identify that it's a city just based on seeing this sort of familiar sentence structure. On this right screenshot here that is labeled entity types, that's just where you can sort of set up your own custom entity types that you might care about. So like account keywords, contact keywords, cities, you can define as many as you'd like for your particular use case. And then at the bottom here, we have that synonym approach. So we might know that we're expecting certain airports, and we might know that users have a wide variety of ways to referring to those airports, whether it's the airport code, the full name, a sort of abbreviated name. So rather than being forced to put each of these synonyms into its own training phrase, we can just upload them as like a dictionary, and then the model will know to look out for any of those synonyms. So once we have this set up on the back end, we get this sort of front-end experience where a user can specify that they need a flight from one city to another. And based on the existing training data that encompasses that type of sentence structure, and maybe having those cities set up in our synonyms list, we can extract them, map them to the appropriate airport codes, and just confirm with the user that they do indeed want to fly from this place to that. So this is a much better user experience than forcing the user to give us, to select the cities from a list or something like that. If they're already telling us the cities up front, we should be able to identify that, grab the cities, and just take them directly to the next step in the transaction. As far as setup and training, kind of similar as far as it's best to do some analysis of what your users are already asking about, so you can identify the main entity types that you care about and how those might appear in real user utterances. As far as annotation, it's important to be very consistent. If you annotate a particular entity as some entity type in one sentence, it's important to make sure it's always that entity type generally speaking, and that entity types are sort of distinct from each other, so your model doesn't get confused at runtime and it knows which category to bucket each entity into. System entities refer to usually like built-in, readily available entity types that a platform might have available for you. And those are things that are sort of general to every use, or like applicable to most use cases. So things like, cities, a city is usually going to be a city regardless of the use case. Maybe like a country, numbers, colors, things like that. Usually your platform that you're using will have those available. So in order to avoid kind of reinventing the wheel, you can leverage the pre-existing training for that. And then you might also have to establish custom entity types for very unique or like specific to a use case types of entities. So if you're working on a use case where there are very specific product codes or something like that, that wouldn't be relevant to the world at large, but is relevant specifically to your use case, that's where a custom entity type would become useful. Fuzzy matching is a tool we have that allows us to accommodate possible misspellings. So fuzzy matching basically just introduces a little bit of tolerance for typos or maybe regional variations. If someone's typing quickly, it's very common that we might get a typo, 2 letters are swapped with each other, or somebody just misspells something. So we should still be able to understand the entity that they're asking about, even if they're not spelling it exactly the way we have specified in our sort of backend synonym dictionary. And then regex rules allow us to define entity types that are defined by having a specific format rather than being a specific word. So for something like a phone number, obviously you can't come up with a synonym dictionary that contains every single phone number in the world, because there are many, many billions or trillions, I imagine. So a phone number is defined really more by the format that it has than the specific sort of content that exists within that phone number. So that's where you can sort of just set up a rule. Hey, if you see something that is this many numbers long and has hyphens in these specific places, or for an email, if you see something that's a bunch of letters and numbers, an @ sign, some more letters, a period. That's where you can sort of really easily capture those types of entities rather than having to worry about, training them appropriately or coming up with lists. And then as far as longer things that you might want to annotate as entities, compound words or multi-word phrases, that works to some extent. Like sometimes keywords just have multiple words in them, and that's fine. But if you find yourself trying to annotate entire like phrases, things that have like a syntactic structure to them, at that point, you might be best served by intent recognition. So entities really work best when it's like a sort of structured keyword type of thing rather than a full sentence or like a phrasal component of a sentence. And most of the time, you might be using intents and entities together. There are some use cases where you might only need intents, which is you just want to route, you want to understand what the user is asking about in general, but you don't care about any of the keywords. You might also have some use cases where you only need entities. Like if you imagine sort of an insurance first notice of loss situation where the user is just giving you a big block of information and you have to extract all the relevant keywords, that might be an entities only use case, but a lot of the time you're using them together. So with this type of flight booking utterance, you're understanding at a high level the user is trying to book their flight, but they're also providing you some sort of keywords that we can extract as entities. So the airport they're flying to, flying from, the city they're flying to, the date they want to fly, the class they want to fly. So these two approaches really are most powerful when leveraged together because we can sort of rapidly understand what the user's asking about and take them directly to where they want to go rather than forcing them to input additional information. And then lastly, I just have some logos here of various tools that you might leverage when trying to implement intent and entity recognition. And these are sort of ordered from sort of most out of the box to most kind of DIY, build it yourself. So tools like Google Dialogflow, IBM Watson Assistant and Knowledge Studio, Amazon Lex are sort of very robust, built out tools that have interfaces that you can use to train your model. So for these, you don't really have to look at much code at all to train your model. You can, and the screenshots, the backend screenshots I showed for the intent and entity setup are from Dialogflow. So you saw there's these, you can sort of cleanly type in the boxes and enter your training data. And they're very sort of easy to interact with GUIs that are, you don't really need that much of a technical background to use. Then we have some more tools like Rasa, Spacey, NLTK, Stanford NLP. So those are more like Python libraries or modules that are geared towards NLP tasks. So they have sort of built-in functionality that you can leverage for some of these NLP tasks I've been discussing, but they're a bit more flexible in that you can sort of write the code yourself in terms of how you want to leverage those modules, what other stuff you want to put into there, like you have more control over the overall flow. And then we have TensorFlow and scikit-learn, which are not NLP specific at all. These are more just general sort of machine learning and statistical model Python packages. And if you really wanted to just build your own sort of intent recognition algorithm from scratch, you could use some of those models to give you sort of more control over the specific, I guess, usage or behavior of your particular algorithm. All right, and that's my spiel about intents and entities. So I'm going to pass it off to Winslow, and they will discuss generative AI.
Great, thank you, Sophia. All right, generative AI is a little bit of a different type of model as compared to the NLU models that Sophia was discussing. So generative AI is usually, it's a class of machine learning model that's trained on a pretty broad generalized data set. And the purpose of that training is to create a probability distribution which can be used to predict what comes next. And so these predictions are what we call generations. So again, usually this is a pretty large data set that's not specific to any domain. It's probably pulling from things like published books, stuff on the internet, Wikipedia. It's pulling information from all over the place, and the training methods can be pretty variable too. It depends on which model and what year we're talking about, but there can be supervised learning, unsupervised learning, reinforcement learning. There are lots of different ways to train a Gen AI model. And all of that training results in a foundational model who is just predicting what's coming next without any real kind of understanding of specific requests or anything like that. So then usually that foundational model is taken and trained again on a different data set, which is more purpose-driven. So that purpose might be following written instructions. It might be responding to user queries in kind of a back and forth conversational format. And then that produces what's called a fine-tuned model. And that's usually the model that is actually made available for public consumption. But it doesn't have to actually end there. Usually you can also continue to fine-tune it even further if you have a more specific goal that you want to achieve. But that's optional. Usually those fine-tuned models that are released are great right out of the box. Next slide, please. So here's a quick example of a pretty classic generative AI use case. So what we have here in the prompt, we've got a transcript from an interaction between a user and a digital assistant. And so we're passing in this transcript, and then we are asking the AI to summarize the above interaction. We're giving it some specific instructions as to how we would like it summarized. And then below we can see the output from this prompt. So we're just taking a transcript, which in theory could be, very long, and we're summarizing it into just kind of the high points. And so this would be something that maybe we do when escalating to a live agent. So this helps them by not needing to read the entire transcript. They can just see this high-level summary instead. But this is a pretty different use case from what we were discussing. So let's move on to the next slide, please. So for a more sort of NLU classification style use case, this is how you can do that with generative AI. So in this case, we are using the generative AI to kind of distinguish between utterances that are referencing a specific event at a mall. And so we are asking the AI, given a user utterance, please identify whether the user is asking about this specific event. And we're telling it, please give these very specific responses if they are or if they aren't. And so then what we've also done is given it a couple examples of already filled out interactions. So if you think back to how these are trained, it's kind of relying on the probability based on what's in the text that comes before. So by giving it these examples, we're giving it it's almost like cheating, kind of tricking the AI. It can't really tell that it didn't generate this. So by giving it these already correct examples, we can improve its accuracy. And so then finally at the end here, we've got an utterance, which in theory came from a user, and then a blank spot for a response. And then below we see that we did get the correct response that we wanted. So moving on to the next slide, please. So as opposed to NLU, the setup and training process is really simple. The model's already trained. It's ready to use right out of the box. You can fine-tune it for your own purposes, but that generally, it requires a ton of data. It requires a lot of time. It usually is more expensive. So it's really not advisable for most common use cases. So most of the setup that we're talking about when we work with Gen AI is actually around developing that prompt that you're passing in. So this should be a trial and error approach. You want to write something, then you want to test it out, see how it's handling requests. You want to test it with both the sorts of requests that are in scope for it, and you also want to see how it's able to handle requests that are out of scope. And then you observe, okay, how did it handle that utterance? Take that output. If there are any issues, you want to think about how you can change the prompt to address those issues. And if you need the output to include something specific or be structured in a certain way, you'll have to figure out how to communicate that in the prompt. So if you think back to the prompt that I just showed, we've got some very specific examples of the type of output that we want, where we want it to either be responding null if it's not in scope for this particular case, or Pizanki if they were referencing the specific event that we were trying to allude to. So another thing to keep in mind when working with generative AI is that there's always going to be a risk of hallucinations and creative interpretations of the prompt. You can kind of craft your prompt to like really fine tolerances, and then the AI can still kind of come up with something that you would never have expected because it's just this sort of inhuman intelligence that it's using. And sometimes the decisions that it makes are not exactly what a human would expect. So you just want to craft your prompt really carefully and make sure that you're keeping an eye on what it's generating to see if it's ever generating anything that is not exactly what you're expecting. And another thing that you can do to help combat this, there are also these hyperparameters that you can adjust sort of as a more programmatic way to guide the output. So this could be things like changing the amount of randomness that's introduced. It could be things like changing which words it's allowed to use, things like that. Next slide, please. So why exactly are we talking about generative AI in a presentation about NLU? It can be used to serve a lot of NLU purposes. One really great way to use it is if you have a pre-existing NLU model and you have a new use case that you don't want to train the NLU model on for whatever reason, you can use generative AI to kind of slip into that gap and fill it. Another really great benefit of generative AI is that NLU tools are usually pretty complicated to work with. There's usually like a relatively high barrier for entry. There's a lot of manual effort involved in getting them set up. Generative AI is usually just a really simple text interface, and it's pre-trained, so it doesn't actually need any specific setup. NLU also has a very rigid output structure, and generative AI lets you decide how to structure its output. So the NLU model is always going to return either one of those intents that you've told it that we care about, or it's going to be returning the specific entities that you've trained it on. But it's always going to be returning those in sort of the same format every time. And that can be either a good thing or a bad thing, depending on your use case. Next slide, please. So I also wanted to throw up a few logos of some pretty classic generative AI tools. So ChatGPT probably needs no introduction, but of course that is a model by OpenAI that's optimized for back and forth conversations. Gemini is by Google, a very similar model that does similar things. Then we've also got Llama, which is from Meta. This one is not optimized for conversation. And then a couple others, Cohere and Claude, which is by Anthropic, a few other big names in the generative AI space. And then Hugging Face also, which is sort of an open source, it's both a platform and a community for working with models like the ones that are listed here, or maybe even other models, maybe making your own model. Hugging Face has great resources for that, and GitHub repositories and stuff like that. Next slide, please. So just for like a really quick comparison of each of these types of natural language understanding. So we can compare like in terms of the difficulty of setup. Intent recognition tends to be really involved, takes a long time, needs a lot of data. Entity recognition still pretty involved, not quite as laborious usually as intent recognition, but still definitely involves a bit of a lift. And generative AI, the setup's usually super easy. You barely need to do anything. And of course, intent recognition and entity recognition are both going to have a really consistent output. Generative AI is going to be much more unpredictable when compared to them. So intent recognition and entity recognition are not super easy to use. Generative AI, of course, is very easy, but there's also a lot less risk involved in using intent recognition and entity recognition because there's more guardrails. You're you have the opportunity to really like craft it to your needs. But generative AI is always going to be kind of this model that was trained by other people. You're not going to know what the training data was that went into it. You're not going to know how it's reaching the decisions that it is. It's not going to give you a confidence score like those other natural language understanding systems will. So the risk is relatively high as compared to them. And of course, the accuracy of all of these is going to vary. It depends on the way that you've trained it. It depends on how difficult your use case is, how challenging it is for technology to understand. It depends on the prompt that you've given it. It depends on how your users are interacting with it. It's always going to be, there's no one size fits all solution. It's going to matter what's your use case and what's going to work best for that use case. Next slide. So this is I guess, Sophia, do you want to take this one?
Sure. All right. Thanks, Winslow. Okay, so now that we've covered all three of these tools and looked at kind of a high-level comparison of across metrics that we care about as far as ease of use, risk, just wanted to talk a bit about more qualitatively which scenario, the scenarios in which you might lean towards one or the other, and sort of the use cases that would lend themselves best to each of these approaches. So for intent and entity recognition, I think the main thing to remember is that those approaches are not generating any novel content. They're just interpreting or classifying incoming utterances and then taking the user to pre-written content as opposed to generative AI, or at least some of the usages of generative AI. So I think that is going to drive a lot of the decision making. So for intent recognition, this might be something you consider if you have a really big sort of knowledge base of FAQs, or you have a lot of use cases that users currently are struggling to find. Maybe they're not accessing the right FAQ submenu. Maybe they don't realize that in order to access the check my balance use case, they have to click through a series of submenus. So intent recognition is a really good approach if you want to just take that stuff, not actually necessarily change the FAQs or give users new FAQs or build out new transactions, but just make it easier for users to access the content that is already there and make it more intuitive. You don't want users to see new stuff. You already have your pre-written content that you're happy with. You just want to route users to the right content more accurately and more intuitively. So that's kind of the main sort of use case in which you might consider an intent recognition implementation. You might think of it if you already have a bunch of good real world data lying around. Maybe it's already categorized into specific buckets. If you have that sort of to leverage, that makes it sort of a lot more feasible to implement an intent recognition approach because a lot of the manual effort and toil really is in acquiring and labeling that data. So if you already have that to use, that's great. And that makes it a great use case. As Winslow mentioned, intent recognition is going to take a long time to set up. So this is good if you have time. You don't need something stood up and running by tomorrow. You can sort of take your time and build it very thoughtfully and intentionally. And then if you have a use case where you really you don't have any room for risk, you really want a very, very consistent, approved, vetted outcome, that's where intent recognition is great as well, because of that sort of lack of creativity and the very consistent output structure that it has. It makes it very reliable and low risk. Entity recognition is something you might consider if you have a form filling or information gathering use case that you want to make more efficient and intuitive. So if you have a type of flow where you have the same 45 questions you need to ask every single user, and it takes them a long time to go through it one by one. What's your name? What's the date that this happened? Please select an option from this list, that type of thing. That's where entity recognition is really useful because if you're expecting the same types of information, you can sort of enshrine those as entity types and then allow your user to provide information in a much more dynamic and conversational fashion. And you can just extract the keywords that you care about rather than forcing them to go through a very, very long static flow where they just have to answer question after question. You might not need to provide any particular content at all to users. You might not need to route them to any particular place. If all you really need is just to understand those keywords and that data from the information provided by the users, entity recognition is going to be a good bet. If you need to do a little bit of both, you're taking users to a particular place based on what they're saying, but you're also extracting keywords, like in that flight booking example, that's where you might use intent and entity recognition together. If you're trying to capture data that can be defined by a very specific format, phone numbers, emails, dates, entity recognition is great for this as well. If you already have dictionaries of possible values and synonyms lying around, if you're like, hey, I have this list of all 2,500 product codes that we care about, that makes your entity recognition setup sort of very easy. If there's like a predefined list of values and it's not really going to change very much, you know exactly what those values are. That's a great use case for entity recognition. And similarly to intent recognition, the setup is relatively manual and time consuming. So this is probably something that you don't want to undertake if you need something like in the next hour. But if you do have time to really very thoroughly investigate different entity types and set them up, then this is a good one for you. And again, it's not risky because the output is very controlled and very predefined. The accuracy is really just going to depend on the use case and the quality of your training. So it's a sort of low risk type of NLU. And then generative AI, on the other hand, so if you want users to see novel content that hasn't been pre-written and is very sort of dynamic in response to what users are saying, really the only way to do that is through generative AI, which obviously is a lot riskier. So this is one where if you have some risk, if you have some flexibility and openness to kind of creativity, and you don't need what users are seeing to be extremely sort of predefined and pre-written, that's where generative AI might be a more sort of flexible or more feasible option for you. And that's for the more sort of less NLU-y, more kind of famous usages of generative AI. For the more kind of NLU-y usages that Winslow is discussing, generative AI is a good alternative to the more traditional NLU setup approaches if you want to fill in some of the gaps. So, maybe you already have intents and entities set up, but there's some new thing you want to extract and you don't want to put it in your standard kind of implementation. That's where you can use generative AI as like a quick fix or a band-aid. Or let's say you do want to implement intent or entity recognition, but you don't have time, you don't have data. You like by the end of the week, you need to be able to have a use case where a user comes in, provides you a whole paragraph, and you extract maybe 10 pieces of data. That's something where you can use generative AI to like fill in the gaps and do that very rapidly without having to go through that more lengthy and data sort of that more lengthy and setup process that has, I guess, very high data requirements. So that's something where you can just curate your prompt to say, the user is going to give you this type of a paragraph. These are the 10 pieces of data that should be extracted. Here's an example of what that data might look like. Please return it in X, Y, and Z format. And it's pretty good at this. Obviously, it's a bit riskier because it's not, even if you're instructing it to return that data in a particular format, it might, say, I'm going to use a period instead of a colon here, or I'm going to use a hyphen or a bullet instead of a number. And then, you might have to be a bit more flexible in how you handle the output, as opposed to something like intent and entity recognition, where there's literally no room for error. It's always going to return the format in exactly the same way. So there is a bit more risk, but the upside of that is that you can get it up and running much more rapidly than the more traditional approaches. And I think that pretty much covers it. So I guess, Winslow, if you have, I don't know if Winslow
Sorry,
had
go
anything.
ahead, Winslow. Do you have something to add?
Oh, I didn't have anything specific. I think Sophia did a great job.
Awesome. Fantastic. Yeah, we are definitely at time. So I think we're going to skip the Q&A session for today, which is totally fine. So if you're watching live, go ahead and put your questions down in the comments below, and then I'll have Sophia and Winslow answer the questions for you. So I appreciate both of you today. We have yet another Pipe Up webinar coming next month. I think we're still determining the topic, but you will see it definitely if you follow Pipestream. So please make sure you're doing that. Thank you again, both of you, and I hope everybody has a great Thursday and a great weekend.
Thank you.
Thanks.